Today we'll be talking about acceptance test-driven development. Basically, first of all, good afternoon to all of you. And what we will be talking here is that how do we ensure that the users are getting what they are asking for. So the first thing which we will do is that what really are acceptance test-driven development. We will also do a comparison between our traditional testing practices like TDD, JUnit, regression testing. And also we will do what are really some of the problems with the traditional test approaches and what are some of the real benefits of doing acceptance test-driven development. Here also we'll be talking about how do we really encourage our users to provide requirements in a real testable format, and also basically to ensure that they are getting what they are asking for. So we will use FitNesse as a framework to demonstrate that stuff of getting testable requirements. At Goldman, we have used FitNesse a lot in lots of projects, small and medium, and we'll also share some of the best practices which you can apply when doing acceptance test-driven development using FitNesse. After that, what we will do is that we will do a small couple of demos. We'll walk you through a simple example and then demonstrate how you can use FitNesse. And then we'll take a case study to really walk you through the FitNesse framework itself. After that, what we'll do is that after you have gone through the demo, we will go through some of the projects where they can really benefit from these practices and also share you some of the templates and the practices of using FitNesse in your applications. After that, we'll take question and answers. With that, let's first start about what are acceptance test-driven development. Basically, we have seen that we have been using TDD a lot, and what really TDD helps us that it helps us to develop units which have small responsibilities, and it also ensures that we can develop quality code, which is really right code. But often what happens is that if you put all these small units together, you want to test them as a whole unit, and that's where acceptance test-driven development comes in. So what acceptance test allows you to do is do a black box testing, and also it ensures that you're developing the right code which really meets your users' expectations. Some of the real essential parameters of acceptance tests are they're really developed in collaboration with your user community. And actually your users get involved initially in the project. When you're capturing requirements, they're also capturing your testable requirements, in which they clearly can tell you in a deterministic fashion what are the exact requirements, basically what part of it, and actually when you execute them, what is the expected result provided by the system. So which means it's really done in collaboration with the users. It focuses on the what part and really not the how part of it. And also basically it reduces the gap between what the system provides and what the users are asking for. With that, what we'll do is that go in some of the benefits of the ATDD, and I will introduce John so that he can walk you through some of the benefits.
Okay. Maybe I should also explain why there are 3 of us here instead of 2 as in the program. I was in our London office and I've been stuck there with this volcano erupting. I've only just got back this morning, so in my absence, Suhas has taken over some of the presentation for us. So that's why there are 3 of us. So anyway, back to the presentation. So benefits of acceptance test-driven development. So this thing about the partnership between developers and users, as you'll see with the demos, we have a way of capturing users' requirements in a testable fashion. So the partnership, we want to work with our users and we want to work with them through the whole process rather than just at the beginning getting requirements and then just at the end doing testing. We want to involve the users throughout and make sure we get exactly what they want developed. So testable requirements, there's often a problem with projects. How do you know, how can you get that sign-off from the users? How can they be absolutely sure that you've developed exactly what they want? And how can you be sure that you've given them what they want? So we'll look at that as well. So this concrete definition of done. What we'll have is acceptance tests, which when they all run, basically you're done. And this project death by requirements. I don't know if you've ever worked in a project where requirements keep growing and growing and the scope keeps increasing and you don't really ever get started. Well, this is another way of cutting that down and making sure you get something executable and running out of the door as fast as possible. Okay, hand over to you, Mohammed.
That's awesome.
That's beg your pardon.
So yeah, just continuing on this, again, one of the basic tenets of agile programming is quick and continuous feedback. And in this case, since users are involved, the feedback is pretty quick, and also it builds the confidence among the user community, because since they are involved in giving the requirements, the confidence level would be pretty high. And also the regression test suite would actually automatically build up, since we are actually taking the requirements from the users. And any major refactorings that you need to take on the code base generally becomes that much more easier, since you have a lot of tests covering these scenarios. And these tests should be seen as something which complement technical testing, in the sense unit testing using JUnit or TestNG, and all other such testing approaches. So this really fits in nicely. It complements other testing approaches that are used in products. Let me hand it over to.
Okay. So although there are many ways of really implementing acceptance test driven development, today what we will be focusing is on a FitNesse framework. That is one of the ways of really getting requirements in a testable format. FitNesse is really a web server and a wiki page for capturing the user requirements in a testable format. So it is a very simple interface which will show you in the demo in some of the examples, where users can really arrange their test cases, they can run their test cases, and they can create their test cases in a real simple tabular format. Now the same tables what are defined on the wiki page, really they get interpreted and executed by the Fit engine. Both the Fit and wiki have been developed by Watt Cunningham, basically to enabling their users to get involved in the acceptance test driven development. Also, we will show you using the FitNesse frameworks how you can enter some of the requirements in wiki, which is a very simple markup language. And FitNesse also provides a capability so that if your users are used to Microsoft tools like Excel and all, you can import those requirements into the wiki format very easily. So what really FitNesse does, it interprets the wiki markup, what has been provided on the web page. It basically executes the fixtures which are written by the developers, and the output of your code is really visible to the users. So suppose user is expecting particular thing, then when you run, the results are very deterministic. If all of your test cases pass, then you will see it's a green light. If the test cases fail, then it says red, and it also tells you what were the actual and what were the expected output. And in case there are errors and other things, it will also indicate you that. So it's really that traffic light signal where you, in a deterministic way, whether the test passed, whether they failed, or were there any problems in executing them. Now with that, what we'll do is that look at some of the underlying mechanics of FitNesse and the inspiration from where it came. John?
Okay. So as Mohammed was saying, FitNesse was developed by Ward Cunningham, and it's an inspired combination of features that you get from JUnit and the features that you get from a wiki. And we'll show you FitNesse in just a minute. So from JUnit, you get the framework to run tests, and you can also run suites of tests, and it will for each test tell you whether it's passed or failed, and you get output summarizing the results. So those are some of the things from JUnit. From the wiki side, of course, wikis, you've got editable web pages, so anybody who can edit them can just go straight in and change them on the fly, and the changes right there for everyone to see. So wikis are great for spreading information across many people. It's in a web page format, of course, so everybody can see it. So you get great user interaction. The users can see their tests, and they can even go and edit them. So with that, I'm just going to switch to FitNesse, and we'll have a look at a very simple example. Okay. So this is the FitNesse page, FitNesse front page. And as you can see, it's a wiki. We've got links to other pages, and we've got an edit button. So let's just click on this one. And again, this page, another example, we've got some more links to other pages which are going to be tests. And this addition test here is a really simple example. So just looking at this, what you can see is here we've got column A, column B, and an add column. And A and B are the inputs, and the add column is the result. Okay, so this is what we're doing here is setting up a few tests. And with the power of FitNesse, we have the test button that you don't often get with wikis. If I press the test button, it's going to run this test and check to see if the results are okay. So let's do that. Ah, okay. So you can see down here, where 3 plus 4 doesn't equal 8, it equals 7. So you can see you've got the summary of what happened. And because it's a wiki, you can press the edit button. And this is the simple kind of markup you get. We can just change that 4 there to 5 and save the page and run test again. Okay, so it's very simple. So you can see, obviously, you can go in, users can go in and set up tests. Well, they can set up the tables. But what's going on underneath the covers? So how are these tests being executed? Well, you see this first line of the column of the table here refers to a Java class. This is all a Java framework, of course. So what you have is the system that you're testing. And then you have these things called fixtures, which are pieces of code which run from these tables. And they'll go and execute the system under test and report the results. So let's have a quick look at this add fixture. And using IntelliJ here. I don't need that. So this is the code that's underlying that particular table. It's got a couple of public fields for columns A and B, and then it's got an add method, and the add method is being executed, and it just returns the result of adding A and B. So these fixtures, this one, as you can see, it extends column fixture. That's one of the fixtures that is built into FitNesse, and so you can extend the fixtures you get there, or just write your own. Okay, so
clearly see, we have been saying there is a collaboration and roles which the user community plays and the development community plays, right? So clearly the green boxes which you can see in this picture are parts which are really owned by the application team. And the orange colored boxes are really the thing provided by the FitNesse framework. So I'll start with the green box. So as on the left hand side, you can see there is a FitNesse test wiki page. So you saw how John defined the test fixture where, A, B, and when he added, the result was coming of that, right? That's really the requirements which the users define using the wiki page, and they define in a tabular format. Now, what happens is that thing what you define really needs to be, when you press the test button, it needs to be interpreted and interfaced with the system which is under test. So in this case, let's assume there is an application which the team has developed, and they really need to test some of the features which has been provided. Now, users have written their test cases in wiki format. The application is ready with their interface. Now, what we need to do is that we need to write application fixture, which you saw the column fixture in this case, right? Now, it really is the middle, basically conduit between the test cases written by the users and the fixtures, basically delegate or dispatches the calls coming from the test to the application under test. Now, what happens is that the FitNesse itself provides you lots of homegrown fixtures like column fixtures, row fixtures, do fixtures, and based on your requirements, you can choose one of them. And here you saw there was a magic, like although FitNesse itself has an underlying web server, because when you define your wiki page, you were just clicking the test button. So obviously this needs to be executed on the server side and connected to the fixture and delegated to the application under test. So what's happening is under the hood, there is a fit server, there is a fit engine, and the fixtures which really do the tying between the test pages and the application under test. And today we will be focusing only on the fit server. Now that's an older version of interpreting the test cases and communicating with the application under test. There are new ways which can be done using the Slim executor as well. but today's focus will be doing only on the fit runner and the FitNesse pages. Okay, with that, basically what we'll do is that we'll explain you the complete thing using a simple case study. Okay, so what we thought is that let's demonstrate really the usage of FitNesse using a case study, which is a simple case study called checkout application. As you can see in this simple checkout, what we are selling is fruits. Now fruits themselves have certain kind of characteristics. Some of the fruits like cucumber and mango in this has very simple pricing rules. So you can see, like if you buy cucumber, the unit price of that is 20. If you buy mango, the unit price of that is 15 rupees. You can also see there are other fruits which we are selling, like banana. It is 30 rupees if you buy single, but there are certain rules that if you buy 2 of them, then you get a special price of 45. So you can see there are business rules, some of them, that when you buy certain fruits, you get a particular unit price, but there are other fruits, when you buy them, you get a special price. So what we'll do is that how the users can define these requirements in wiki, how do we define fixtures so that we can interpret them, and also we'll look at the application under test. Now in this case, we are not going to focus much on the application itself because our focus is to talk on the wiki and the test fixtures. So at the bottom of the page, you can see there is a simple application which the team has developed, and let's assume it provides an interface called checkout. And what it provides you is that you can scan an item. Basically, you can go to the counter, buy some fruits, and also you can ask for what is the total price. So what we are saying is that if checkout is an application and if you treat it as a black box, when you scan multiple items, what happens that you are really interested in the total price. So in this case, if you buy apple, banana, and cucumber, what would be the total price when you have purchased them? So the intent here is there, basically how you can use FitNesse to define these requirements and how basically the developers write fixtures to interpret those requirements. So what I'll do is that before handing it over to John to do the real demo, we'll just show you really how the domain looks like. In this case, the domain is very simple. As you can see, there is a checkout application and there is a pricing strategy which the team has implemented, and based on whether it's a simple or a complex, you can configure the checkout with the right pricing strategy. So the focus is not much on this. So what we'll do is that we'll go straight to the demo now. John.
Okay. Thank you. All right. So back here on our FitNesse page, if we go back to the main page here, first of all, we're going to look at the simple example where you just have simple prices. So no matter how many cucumbers you buy, they're going to be 20 each. So let's have a look at a FitNesse test for that. So this FitNesse test here, it's structured so you set up what you're going to be testing. So at the beginning here, we set up a pricing strategy. We've got the name of the item and the price. We set up a checkout with that pricing strategy. As you can see, with it being a wiki, you can annotate these examples and make it really clear to the users what's going on. And then down here, we've got the actual scanning going on. So we've got set up our checkouts, and we buy a cucumber, we scan it, check what the total is, and so on and so forth. So should I run this page? All I have to do is just press the test button, and let's see what we get. Okay, so this test looks like it's worked. What I can do, as it's a wiki, is I can go straight in, edit this page, and let's say we buy another cucumber. What do you think the total should be? Everyone been keeping up with this? Buy another cucumber. The total at the moment is 90. What should the total be? No? Okay, let's try 110. Let's see if that works. Okay, and we save the page. Test it again. Okay, so you can see this is a sort of This is the sort of thing that the user can do. They can go, okay, what if I buy another cucumber? The total should be 110. Let's put that in, run the test, and see if it works. Okay, so what we can do is have a quick look at the underlying code for this. We'll have a look at the fixture for this piece here, the check scan, and we'll have a look at the underlying code as well. So let's have a quick look at that. Okay. This is the code for doing that check where we scan the item and check the total. So you can see here that this fixture has got a checkout that's being passed into it in the constructor. So this checkout, this is system under test. And it's got this public string item. That's that item column. So that's where we enter the item. And then finally, it's got this method down here, check, where the checkout scans the item, and what it returns is the total price from the checkout. So you can see this is a much more realistic example. We have a system that we're testing, and we're testing the public API of that system. Okay, any questions about that? How the values getting passed? Okay, well, actually, if we go back to the page, what will happen is it will execute that. It'll execute for each row. It executes that code. So for each row, it will set the item and scan it, and then return the result. So it does it multiple times. It does it once for each row, yeah. So it sets the value and does the scan. Okay, now we're going to look at a more complicated example. And that is our example where we want to do n for the price of x. So buy 2 bananas, and it will cost you 45 instead of costing you 60. So let's have a quick look at that. And that's a special price checkout. So here, and again, just going over how you'd set this up as a user, we're setting up the pricing strategy with one particular pricing rule. This particular one here is for apples. So say, okay, for apples, normally they're 50, but if you buy 3, it'll be 130. And then here we've got the test for the apples. So what happens if you buy 3 in a row? What should the total be? And the user's gone in here and, okay, what if you buy 4 apples? What if you buy a whole load of apples? And then he's also set one up for bananas. Okay, we'll set up a pricing strategy with a pricing rule for bananas and see what the totals are. All right, so if we test this, so let's imagine our user's gone in and set this up. If we test it now, okay, so we've found out that it's gone wrong, and that's because we're doing acceptance test-driven development here. We've got the test, but we haven't written the code to actually fulfill the test yet. So if we just look at the code for this, what we do then, and this is a typical kind of cycle that you go through. You get some requirements from the user. Initially, they'll fail because you haven't written the code yet, and then you go in and write the code to fix them. So I have this code I've already set up, but so I don't know if it works yet. So I'm just going to uncomment it, and I'll make the code. All right, and then switching back to FitNesse. So it's very interactive. I press the test button. It's picked up the new code, and now they all work. Okay, so I think that's illustrating how clear it is from a user's point of view, and from a developer's point of view, how easy it is to prove that the tests are correct. And another thing I was going to show you was this thing about running suites, because in JUnit you can run suites of tests. And it's the same thing here. We've got this page here has actually got links to these tests. It's actually a suite of tests. And as you can see up here, there's a suite button. If I run that suite button, it's going to run all the tests in that suite. And you can have suites which consist of other suites, which consist of other suites, and so on. So you can have your tests structured, and you can run the entire set of tests. And you can run these things not only from a wiki, you can run them from a command line as well. So typically, you'd have part of your continuous build suite running your top-level suite, which is going to run all the tests that you've written. And you get the results back from the tests. You can use those as build artifacts. So it's just forms part of your normal continuous build cycle. Okay, just hand over to... Yeah. They run sequentially, one after the other. Yeah. You can run them in parallel, but generally, by default, they're just going to run one after the other. Any other questions on that? Yes.
I have one question regarding the setup for the dividers, the work. The fixtures, should it be written by the developers and these test cases by the testers?
Yes, that's the way to do it, because the fixtures, you need some Java code to do that. So developers write the fixtures and provide them for the users to use in a simple fashion. So you could probably set up some example tests for the users to get the hang of it, and then they can go in and do the rest. One thing you might have noticed if we go and edit this page is that down at the bottom you've got this spreadsheet imports. So if your users have their requirements as Excel spreadsheets, which a lot of ours do, it's quite easy to take the spreadsheet and import it into the fixture, the page.
And also, if the users write the wiki pages and for example, the developers are developing fixtures, you can then sanitize the wiki pages or also give them a template so they can define those wiki pages, and then you can enrich it with your own fixtures, what you have written. But the fixture code itself is provided most by the FitNesse framework, and it has very light logic because it's only dispatching it to the system under test, right? And hopefully the system which you're testing has a very good public interface for testing.
Yeah, it does encourage you to write good public interfaces to help the testing.
Yeah, so this again, the next 4 slides are, am I audible? So the next 4 slides are essentially to explain whatever John said. So it's a recap of whatever John mentioned, but with more emphasis on some of the fixtures that we used in this demo. So this is a screenshot of whatever John just demoed. So if you look at it, it has a nice flow the way it actually works. You have a setup initially, so you set up the data, then you perform the action on whichever system you want to test, and then you assert the behavior. So it has a nice sequence of steps, which is very easy to understand, and it's nicely set up so that the users also find it very easy. And one of the questions that might have come up is like, how did this magically transform, whatever was put here, how did it actually map back to the fixture classes that we have? So if you look at the first line in the screenshot we have here, we have the checkout fixture. So this is the fixture class that gets invoked when this test is run. And we are actually calling this methods on this fixture class. So the setup pricing strategy, the header that you actually see on the first table over there, this is actually going to be concatenated and camel case, so you actually end up getting a method. So you would actually have a fixture called checkout fixture with a setup pricing strategy method, and then it sets up this data. Similarly, we have this one, the checkout scan fixture, which is actually one of the fixtures that gets called when we call setup checkout. And within the checkout scan fixture, I have a public variable string item, and that is the first column in my final test data. And the check and the question mark indicates essentially the question mark indicates that this is the return value that I want, and check is the method that gets invoked, and we actually assert what the behavior is. Again, as we mentioned earlier, there are a lot of default fixtures that FitNesse already provides. So one of them is column fixture. And again, column fixture is essentially very useful when you want to do some kind of repeatable test with different input data. Like for example, in the simple test fixture, we had quite a few different combinations wherein we wanted to actually input cucumbers, mangoes, and then see the output. So it's very useful in such scenarios. And a fixture, again, is something which should never have any business logic, because it should be very thin. It's an interface between your system and the FitNesse framework. And the default fixtures which are actually provided by FitNesse should definitely be used. You should subclass those and add any custom behavior that you want to. Do fixture is, again, one of the probably the most often used fixtures. So it allows you to actually kind of put the test in a nice English story-like fashion, wherein you say, like, do this first, do this next, and then again assert the behavior. So this is probably one of the ones which you would use most often, like we have actually used in our tests over here.
Actually, should we show how that maps to the page? So this is called checkout fixture. And you'll see it's got set up pricing strategy, a method here, which returns a fixture. It's got set up checkouts, which doesn't return anything. And it's got check scan, and that method returns a fixture. So this fixture here returns a pricing strategy setup fixture. This one here, you can just about see from the code, it sets up a checkout impl with a pricing strategy, which it's got from here. And this one here returns the checkout scan fixture with the checkout that we've set up. So we can have a look at the checkout fixture code and see those public methods. And yeah, so that's just what we saw in the code. And if we have a look at the FitNesse page, you're going to see how those public methods tie up with what's in the page. Yeah. So there's the fixture name at the top. Set up pricing strategy, that was that method, set up pricing strategy. And set up checkouts. These are all the methods that we saw in that do fixture.
Yeah, this is pretty much what John actually just explained.
Yeah. I think what we have done is that at Goldman we have used FitNesse for many of the large projects. And what we have seen is that if your application has lots of business rules, like as we saw in the checkout application, that there were different pricing rules, and it's very easy for users to define what the expected output is, and the system really will do the actual results. So what we do is that wherever there is a requirement and the requirements can be expressed in a tabular format, those projects can really benefit from this. Also, if there are complex and volatile business rules and you want to ensure that whatever your system is delivering really meets the expectations from the users, you should go ahead and use FitNesse over there. And basically, wherever obviously the requirements were fit in a table format, right? We discussed only the column fixtures where it was really compute kind of things which you are looking for. But even when you have like rows of data and you want to compare like query kind of thing, so for a reporting application or something, there also you could use FitNesse. So there are row fixtures as well, which allows you to do that thing. So wherever there are lots of business rules, data could be specified in tabular format, and really you want to ensure there is no ambiguity between what users want and what the system provides, we encourage using FitNesse for those kind of projects. Some of the, what we'll do is that we'll spend some time on defining some of the good practices. What you saw, like John demonstrated, like how you can use test suites to really basically define your test cases in a very manageable format, right? Because over a period of time, there will be lots of test cases and it can get bloated. So what you can do is that really you can provide suites of suites, and then you can configure your tests within them. So we encourage doing that thing, because that way your test pages become very manageable. Now you saw one of the patterns which we used while doing the testing itself. The pattern itself you saw was that clearly what we do even normally in our unit test cases, we set up the thing, we do action on it, we verify, and then we tear down, correct? So same kind of pattern you can use while doing your requirement testing, but it's as a more broader level. So we encourage that you start with your setting up your data, what you want, then basically set up any of the initialization which you want to do, like setting up your application, then really action, basically operate on it and do certain things on that, and then verify whether what the system is really behaving the correct way, and basically you can then tear down the application itself. So you could use that pattern using the toFixture a lot. We already shown, like in the demo, how did we use toFixture to do that. Obviously, you can see the artifacts which are getting generated here are the wiki pages which are done by the user community, and there is a fixture code which the developer community is doing. So we encourage, both of them should be versioned and they should be managed in a repository so that you can, version them and you can, deploy them properly. So that's one of the things you can do. You see, one of the things we have emphasized that the users are really getting involved and they are really providing the requirements in a testable format, right? So it's very important that wherever you want to use acceptance test driven development in your projects, it's important that the users get on board with the projects early on. Because you can see, although the wiki has a very minimal kind of a format and syntax, it's important that the user understand that whatever they are asking for, they can really define in a very deterministic fashion, and they can use wiki as a tool to define that. So we encourage, wherever we have used ATD practices, we have encouraged our users and they have got on board early on the project itself. And there is minimal kind of teaching also required. They have to understand that they have to collaborate with the developers team and they need to provide those requirements in a format which is really in an executable fashion. So it's important that if you want to use these practices, encourage your users to be on board with you early on itself. Yeah.
That's a very good question. So how do you get the users on board was your question. I think you need to get them, you need to really show them, demonstrate that this process works. So luckily we've got several projects where we already use this approach. And I think once you've shown an example to the users, they usually really like it and they can appreciate that they're going to get testable requirements out there, and they're going to get quick feedback on whether they've actually got the system that they're after. So I think the key to it is to, if you haven't done this before, do a pilot and then use it to demonstrate to the users how this whole process works.
Right, and once I think they see the results of it, they start liking it, and probably they will be on board looking at the results itself.
Yeah, in our experience, I think users are, once they've seen it and they've had a go, they're very keen. They like it very much.
Yeah, just the last 2 points before we take some more questions. Integrated with any CI or continuous integration if you already have it. Like if you have JUnit test suite being run with continuous build tools, your FitNesse test also should definitely be part of it. And fixture code, it's Java code, so follow all the good object-oriented principles. Promote reuse of the fixture code so that they can be any common framework-related fixtures that you have, you probably should be reusing them. So this is again another good practice which again we follow a lot in GS. So with that, if you have time, probably we can take a few questions.
Please.
How relevant is this testing framework with applications where you exchange data through XML?
Sorry, how relevant is this to applications where you exchange data through Excel? XML. Oh, XML. Have you done that at all, Mohammed?
We have not used XML, but if you can basically, so are you saying that you're using XML as your exchange mechanism between the applications? Now, obviously, there is a contract between the two things, like when you get an XML, what kind of things you expect, right? And what is the behavior, what will happen when the XML is consumed, correct? So many of the rules could be defined in XML or some logic, right? So if you could say, if you're providing this kind of an input and this is the expected output, you could use for doing that as well. Because really what XML is telling is a message, right? Or some kind of invocation, and certain logic is happening there. Because XML itself is it just a data payload, or you're also expecting certain behavior when the XML is consumed?
Just like going by an example, recently we
Mhm.
Basically, you have different web services,
Mhm.
moduling each of the systems as a web service. You're going to call it. So
Correct.
yeah, you have to check both. I mean, whether the output is right. At the same time, you also have to go by the values and
Mhm.
each value which is coming is right or not. So is it something which we can use in such a scenario?
Well, we've used it not for XML, but for internal messaging formats. If you, it's fairly straightforward to write your own fixtures, which can, as long as you can put your data as a table, it doesn't have to be exactly rectangular table. You can have, as long as you can interpret the table, you could put your XML in rows of the table, and then you can run it through and check that you get the same results out. So it does work. It's easiest to work with tabular data, but you can write your own fixtures which will interpret whatever you want to put in and put out results. So it has this whole framework for telling you and displaying on the screen if something's right or wrong. And because it's all open source Java code, you can go and look at the actual way that it runs and change it to do whatever you want.
Yeah, there are lots of extension points provided, so you could write custom fixtures as well.
Yeah, actually we are using this functionality in one of our project where we are reading the XML files from the file system and we are processing those files, and then we are creating some another XML files that are consumed by the database.
Good.
So what we are doing there is we are just loading the context of the application into the fixture, and that starts reading the file from the file system. And when the files are written on the file system, we can just write some code that will read the output of that application, and from those XML files, we can use XSLT to access the different values on those XML, and then we can verify on the FitNesse pages. Apart from that, if you are using the web service, then we can get the response from the web service, and then XML can be verified using writing some of the fixtures, and then using those fixtures on the FitNesse pages.
Good.
Okay.
It's like acceptance-driven development. Probably you are bringing more of your customers into the development cycle. It's a little different than the traditional software delivery model. Wouldn't you feel like this is overall impacting the entire development process? It's consuming more time by introducing this process?
Other way, actually, it complements that, because often if the users are giving requirements, let's assume using UI mockups or they're using prose documents, often it happens is that the requirements itself, what they provide and what the software delivers, there is sometimes a mismatch, right? And although we think we are delivering something, we have seen that they say no, this is not what we wanted, but this is what we want. So again, you go back and you do the things. Even if you were using Agile, many iterations you give, the customers keep on saying, this is not what we asked for, right? So really what FitNesse or these acceptance tests are giving, if you're involving users early, they can really give the requirements in a more deterministic fashion, right? So if I'm doing this, this is my expected output. And if the system doesn't do, then there is a clear kind of a feedback which is given early and continuous to the users. Obviously, I mean, there is some kind of a teaching we need to do to an earlier question, like how to get users on board with this process itself.
Actually, I've got another point on that would be, as you can see, you need user involvement as you go along. So you need to have a pretty good relationship with the user. They need to be easily accessible so they can give you the input as you go along. But in terms of the amount of work that's involved, it's really the same amount of work, in fact, probably less work, but it's spread over the project instead of coming maybe right at the end. And as it's coming while you're developing, you'll find that you're building up a suite of tests, and you just, by the time you get to the end, you don't have a big period where you're doing a whole load of more user testing because it's already been done. So I think that's, if you've got that kind of relationship going with the users, it works really well.
I would like to add on that as well, because this is especially used when the application is a backend application and there is no UI. So your end customer doesn't know whether the application is working fine or not. So it provides a UI whether the client can see the actual results. And he can see if you are giving some input in the UI, in the wiki pages, then he can verify whether the results are proper or not.
Exactly.
Otherwise, for a backend application, it's really difficult to show the client that the application is working fine or not. So he can accept the functionality that his backend application is working fine or not.
Yeah, and often you get people thinking, well, how are they able to give you these requirements? Well, what you'll find is, how do they know what the right answer is? And you'll find that when the thing goes into production, they know what the right answer is. So they definitely know what the right answer is. So it's a question of teasing it out earlier in the process. Okay.
Okay.
Any other questions? We can take one more. Yeah.
Support for other languages?
Yeah, the Fit itself is the backend engine which has been ported for other languages like C#, Ruby, Python, Smalltalk as well. Yeah, see, the mock objects, because anyway, if you were doing unit testing, right, you might be mocking out your other interfaces because they might not be ready. But in reality, what FitNesse is giving is a holistic end-to-end test, right? So if you have already those features available, you should not mock because really you are doing an end-to-end integration test. But at times when you don't have available, you could mock them out. Yeah, because see, the output which you get back, obviously in your case, you would have a list and where you have domain object which is defined, which is a department, right? So you could use row fixtures and array fixtures to accomplish that as well.
Okay, I think that's all we have time for. Thank you.
Thank you for